Yeah, welcome back. In this class, we are going to discuss about some complex Boolean expression stick diagram using Cmos logic. Now you can observe here, in the Boolean expression y is equals to ab plus cd whole complement, the inputs ab is going to be have an AND operation. The input cd is going to be have an AND operation. These two are having AND operation, but they are going to be have an OR operation. Okay, therefore the small trick to design a CMOS stick diagram using such type of complex Boolean expression is maintain the continuity when you are having same type of operation. That means for AB, maintain the continuity for CD also, but when you are going to do the OR operation of both, then discontinue this two expressions, that means AB and CD, then try to perform the entire Boolean expression. Is it clear, all of you? Then once again we will see, observe very carefully. Okay, y is equals to AB plus CD whole complement. Now you can observe the schematic diagram of it. Now you can see this is AB. Is it clear? This is A and this is B, and you are having CD like this. Is it clear or not? CD. Okay, now you can observe this one. Now you can observe there is a continuity for this. Why? Because these two are in parallel and these two are in parallel. Are you clear or not? But when you are talking about these two are in series, then definitely you do not have any continuity, right? Therefore try to discontinue it and try to connect the stick diagram. Is it clear, all of you? Now once again I am going to draw the schematic diagram of the Boolean expression AB plus CD. You can observe it. Now I am going to consider, okay, this is AB and this is for CD, and in Cmos this is for AB and this is for CD. I hope that are clear. And it is given to what? VDD, and it is given to what? VSS. Now you can observe, let it be A, let it be B, let it be C, sorry for that, let it be D. Okay, this one let it be D, and this is A and this is B, and here it is C and here it is D, and the output is taken between pull up and pull down network. Now for this entire thing we have to design a stick diagram. Now observe very carefully. This is source terminal, it is a source terminal, it is a drain terminal, it is a drain terminal, and it is a source and it is a source, it is a drain terminal, it is a drain terminal. Now I already said in the last class, in series take whatever may be the terminal's name, but don't forget the output is always at the drain side and the power supplies are always at the source side. Therefore it may be drain, it may be drain, and drain is there, therefore it may be source. Since it is source, then definitely it may be drain. Okay, here also since it is source, it may be drain. Here drain is already there, therefore it is source. I hope that are you clear. Now observe very carefully how to design a stick diagram. That is a very important point you have to talk about. Now you can take, this is the demarcation line. You can observe this is a demarcation line. Okay, now I'm taking the polysilicon. How many polysilicons we have to take? Anybody from the class? Absolutely 4 polysilicons we have to take. This is one polysilicon, this is other polysilicon. Are you clear? This is another polysilicon. Is it okay? Now here I said to break the continuity. I will talk about that. Okay, this is another polysilicon, and don't forget this is another polysilicon. I hope that are you clear. Now 4 polysilicons are there. Why? Because 4 inputs are there. Now if you observe that, okay, now I'm going to cross the diffusion. I will use different color. Why? Because it is not that much effectively appearing. Okay, then I will use some other color. I will use a black color for that. Now you can observe that. Okay, this is polysilicon. This is actually what we are doing. Is it clear? But I said to break the continuity. Therefore, what should you have to do means, don't cross the diffusion entirely. Cross the diffusion wherever there is a continuity. Here AB and here CD. This is an important point you have to remember for such type of complex expression. I hope that are clear. That is known as discontinuity. Is it clear? Here for this one it is CD. Are you clear? Okay, now you can observe that here. Let it be this one is a polysilicon. Therefore I am considering such type of lines. I hope that are you clear, all of you? Yeah, absolutely. And okay, now the above transistors, above demarcation line, what transistors they are? PMOS. And below demarcation line, what transistor they are? NMOS. Absolutely. First of all, we'll talk about PMOS. If you observe that PMOS, let it be source. Okay, let it be, what should we have to assume? Drain. And let it be drain, then it becomes source. Now let us consider it is A and let us consider it is B. Okay, now you can observe that very clearly. The source should be connected and the drain should be connected. Here the drain is already connected. Therefore you have to use source. Therefore I am using the source. Is it clear? Then I am connecting the source here like this. Then it becomes a contact. Okay, then how to represent VDD? Absolutely, VDD should be represented with a cross mark. This is VDD. Okay, then drain is already connected. Okay, now you can observe that the CD MOSFETs of PMOS transistor, you can observe that. Now let it be source and let it be drain, and here also I am doing the same thing. Okay, now you can observe that I am assuming it is a drain and it is a source. Then what should you have to do, guys? Then you have to do that, you have to connect the source. Absolutely. Then the same process I am going to do here also. It is a source and okay, there is a contact and there is a contact and you are having a metal. I hope that are clear. That means this connection is completed now, and drain this connection is also completed. This is also completed. But don't forget, very importantly, okay, the drain connection of AB should be connected to the source connection of CD. Where is the drain connection of AB? There it is. The source connection of this one is this one, right? Therefore we have to connect like this. Okay, then you require a contact here. Then you have to extend the metal like this. I hope that are clear. Okay, now the PMOS entire connections are completed. Now we have to talk about what? Yeah, absolutely, NMOS. Now I said already for NMOS, if there is a series, take whatever it may be. Now let us assume that it may be a drain. Okay, it may be source, it may be a drain, and it becomes the source. Now this is A, you can observe this is A and this is what? B. Okay, now I am taking intelligently, you can observe that I am taking this one as D. Is it clear? I am taking this one as D, and if you observe that I am taking this one as C. Okay, why there is so much confusion for you? No issue, I will take this one as C and this one as D. Are you clear? And you may observe that for this drain is there, source is there, then drain is there, for source is there. I hope that are you clear. After that for C also, what is there, guys? Yeah, drain is there. Absolutely. After that source, drain, after that source. Now very important point, the source of drain and the source of the source of D and the source of B should be connected with each other. Now I am going to use that one. This is the source of B, this is the source of D, therefore I have to give the connection here. Is it clear, all of you? Now you can observe this. I have given the connection here. I join the source of B and I join the source of D, and these two given for VSS, therefore VSS is given as a cross mark. I hope that are clear. Okay, now you can observe that the drain of A and the drain of C should be connected. Where is the drain of A? This is the drain of A. Okay, drain of D is there, therefore these two should be connected. I hope that are you clear. These two should be connected like this. I hope that are you clear. These two like this you have to connect. Then there is a metal here, sorry for that. Okay, suddenly something came here, I think so. The entire design is went because I pressed the delete button. Sorry for that. I hope that you understood that, right? Okay, shall I repeat one more time? Yeah, absolutely. Then you are having a demarcation. Sorry for that. Unfortunately, I pressed something. Okay, now you can observe that I can consider a demarcation line here. Okay, now we have considered a polysilicon here. I hope that are you clear. This is polysilicon and this is a polysilicon you have considered, and this is a polysilicon you have considered, and we pass as diffusion by breaking the continuity. Here also we crosses diffusion by breaking the continuity, right? Like this. Okay, we connected these two and we said this is a metal, right? And we have given the VDD for this, and here we connected these two. Okay, and we have given a contact here. Okay, the source are connected, the source are connected, and we said that this source combination is going to be connected to the drain of this. Okay, no need of any extension, and here there is a contact, right? For Nmos I will take some other color. Now you can observe that this drain and this drain is connected. Is it clear? Okay, now you can observe that this source and this source is connected. The source of A, this is A, this is B, this is C, and this is D. See, B drain as D drain is connected, you have to connect the source of sorry for that, I will use, okay, we have to connect the source. Okay, and here we have to give the cross mark and we have to tell it is VSS. I hope that are you clear. Now what are the remaining connections we are having? If you just observe your schematic, I will talk about the schematic like this. This is AB and it is CD, and it is AB and it is CD. It becomes VSS, it becomes VDD, and it is your transistor A. This is A, this is B, this is C, and this is D. I don't have sufficient space for that. Okay, let it be D, and similarly here A, B, C, and D. Now we completed source connection, drain connection, and source connection, drain connection, and here also we source, this is drain, this is drain, this is source, we completed that. And here source, is it clear? And it becomes drain. Here there is a source, it becomes drain. Sorry for that, I wrongly mentioned. Why? Because the output is always at the drain side. Therefore these two become drain, drain, then it becomes source. It is a source, it becomes drain, then it becomes what? Drain, already completed, therefore it becomes what? Source. Since there is a source, it becomes drain. Now you can observe source is given VSS, this is completed. Drain is given, and you can observe the drain, this one, these two one. Okay, now what should you have to do? The drain of this and the drain of this one. Okay, where is the drain of CD? This is the drain of CD. These two should be joined. Okay, then that means very important point is this is the drain of BD. Then you have to join this. I hope that are you clear. Then this is known as an output of U. This is an output of Y. I hope that are you clear, guys. In this manner you have to design a complex Boolean expression using Cmos. Okay, this is the way to design how any complex expression in Cmos. Shall we see some other complex expression? Okay, now you can observe the complex expression. Let it be y is equals to AB plus C whole complement. Why I am considering whole complement means if I didn't consider a whole complement, I have to draw an inverter. That is the reason why I am considering whole complement. Now you can observe very clearly, since three inputs are there, in that AB are in parallel, therefore definitely you have to consider AB in parallel. Now C is in series, therefore definitely you have to consider. For NMOS, AB should be in series, this is A and this is B, and C should be in parallel. This is, sorry for that, this is C, and this should be connected to VSS. This should be connected to VDD. The output is taken between what we'll call pull up and pull down. Now how to draw? Will you please tell me somewhat quickly? Absolutely. First you have to draw a demarcation line. After that, absolutely, you have to consider polysilicon. How many polysilicons you have to consider? 3 polysilicons. 1, 2, 3 polysilicons you have to consider. Why 3 polysilicons you have to consider? Absolutely. Why? Because there are 3 inputs. Then continuity. Will you please tell me the continuity of that? Anybody? Yeah, absolutely. AB, you have to take these two in continuous nature and this as a separate nature. Are you clear? And here also these two in continuous nature and this as a separate nature. Okay, now it is what? A, it is what? B, and it is what? C. Now you can observe that the source, it is a drain. Since the output is taken at drain, it becomes source. Then since it is output, drain, since it is supply, source. Drain is completed, therefore it becomes source. Source is completed, therefore it becomes drain. Okay, these are the terminals. Now you can observe that the source of AB should be connected. Let it be source here, this side. Let it be, I will use different color for that. Let it be source, then it becomes drain. Then let us assume drain, it becomes source. Therefore I am connecting the source to source. Yeah, okay. Then these two are joined with the help of contact, and therefore you have a metal here. Then how to give VDD? Absolutely, VDD should be given with a cross mark. This is your VDD, and drain already internally connected. Okay, now observe that the drain should be connected to the source of C. This is, let it be the source of C. Okay, let it be source of C. Okay, then drain should be connected to whom? The source of C. Absolutely. this should be happen, right there. Okay, then you have to connect like this. And is it understood? Then this connection, PMOS connections are completed. Now you talk about NMOS. I already said that in series, take whatever you are having, drain, okay, source, then it becomes drain, it becomes source. Okay, now if you observe that in NMOS, let it be source, let it be drain. I hope that are clear. Since the source of what we'll call B and the source of C should be joined together, therefore you can use the what we'll call same diffusion to join these two. Okay, but don't forget here you have to give VSS, therefore definitely you have to take a metal extension there, and you have to give a contact, then you have to give the cross mark. I will use different color for cross mark. Why? Because it is not appearing that much effectively. Okay, you have to give a cross mark here, VSS. Now what is the remaining one? The drain of A and the drain of D should be given. That means you have to observe very clearly here. This is the drain of A and it is the drain of C. These two should be joined together and a contact is taken here. I hope that are clear. Okay, in this fashion you have to design. After that, the drain of A and the drain of D should be connected to the drain of C. Where is the drain of C? This is the drain of C, therefore you have to connect to the drain of C in this fashion of PMOS transistor. Is it clear? Here, is there any contact here? No. Why? Because same metal is going to be connected. Then that's it, the connection. Where is the output you have to take? Yeah, in this position you have to take an output. This is called Y. Is it understood? In this way you have to design the stick diagram of any Boolean expression, complex or normal, using Cmos. Is it clear? Thank you very much. If you are having any queries, please comment. Have a nice day. Thank you very much.